Hello and howdy once again, everybody. We're looking at question number 4 on practice quiz number 5. If possible, simplify x going to infinity, or the limit of it as x goes to infinity, of x minus ln x. So, okay, it's another limit question. And just as we remarked in question number 2, we haven't really been doing limits a whole lot. So it's likely going to be a L'Hopital's rule sort of thing. That's the most recent pure limit style thing that we've learned about. Why didn't we remark this in question number 3? Well, question number 3 also has a sigma in it. So that's sort of talking about our newer sigma notation style work, our first principles work. But this right here is just a pure limit. Okay. So what can we do? If we suspect L'Hopital's rule, then we should just plug in and see what sort of indeterminate form we have. And if we don't have an indeterminate form, we'll have to come up with a new way to do this. Well, as x goes to infinity, the x is going to infinity. And as x goes to infinity, ln x also goes to infinity. Okay? It's important to remember, ln x, as x approaches 0 from the right, goes to negative infinity. As x approaches infinity, ln x goes to infinity. But this is an indeterminate form that we are familiar with. Remember, we have 7 indeterminate forms: 0 over 0, infinity over infinity, infinity minus infinity, 0 times infinity, 0 to the infinity to the 0, 0 to the 0, and 1 to the infinity. If we don't see any of those forms, well, we've got a bit of a problem and we've got something else to do. Okay, well, it's infinity minus infinity, and we might think, well, gee, how did we do the infinity minus infinity in class? Well, when we were presented with a question like this in class, we had fractions. You know, one fraction minus another fraction. And so what were we able to do? We were able to combine it as a single fraction. And then when we plugged in again, we got something over something. But here I don't have that. I have x minus ln x. And there's no fractions to be seen. So what can I do? Well, you might remember at the very end of one of the classes, depending on what class you're in, morning or afternoon, you might remember I gave you this big chart that said, if you're having trouble converting between one form or another, try something like this. So we can actually try to convert this into 0 over 0 or infinity over infinity. Okay? Now, I don't know which is going to be best, so we'll try them both. If I've got f of x minus g of x goes to infinity minus infinity, and I want to convert it to 0 over 0, I do 1 over g of x minus 1 over f of x all over 1 over f of x g of x. Now that might seem complicated, but if that's the only thing we can do, then that's the only thing we can do. Now in this case, my f of x would be x, and my g of x would be ln x. Now I'll tell you why I don't like this. I want to do what I'm seeing here. I would have to have 1 over ln x for this part right here. And as I've mentioned before in class, I try to keep my lns on top whenever I can. I don't like doing 1 over ln if I can help it. 1 over ln, 1 over an arctan or an arcsecant or an arcsine, those are the things I especially try and avoid. Okay? That's just from experience. You do enough of these questions, you realize I don't want to do the derivative of 3 over ln squared and things like that. Okay, so yes, we can do this with 0 over 0, but let's try and remember infinity over infinity. There's no reason you have to do 0 over 0 or infinity over infinity. You can do either one, whichever one gets you the answer. And if one gets you the answer, the other one will get you the same answer. Don't worry about that. It's not, oh, Professor O'Hara always uses 0 over 0, so that's what I've got to do. Go with whatever's easiest. And actually, in this case, the infinity over infinity situation is better, because if I have f of x minus g of x and they both go to infinity, what can we do? Well, we can ln and then get e to the f of x minus g of x. Okay, a sort of rewriting thing that we've done many times before, many times. The ln and the e just cancel out, and we're still left with f minus g. But we can rearrange this. Thanks to those fun little properties of exponents, when we subtract in the exponents, we can it becomes a big old division. Okay? So, watch what happens now. Okay, and this is going to be really nice and easy because look what happens to gx here. E to the ln x is just going to be x. So we'll replace this with ln e to the x over e to the ln x. We'll do a little bit of simplification here. E to the x, and then all over x. And guess what? Ln is continuous, so the limit gets to pop inside. Look at that. So now to answer our original question, we just need to answer this inside limit. So let's do him separately. E to the x over x. And once again, I'm going to plug in. I haven't ever done L'Hopital's rule yet, and I'm not done a L'Hopital's rule question until I've at least done it once. Well, e to the x as x goes to infinity is going to go to infinity. X goes to infinity as well. Ah, this is prime for L'Hopital's rule. So we'll just very quickly take the derivative of both the top and the bottom. E to the x has a derivative of e to the x. X has a derivative of 1. So this is really just the limit of e to the x as x goes to infinity. But we just mentioned that. That goes off to infinity. Okay, well that means that this limit in here can get replaced with an infinity. You know, what's ln as something goes to infinity? Infinity. And so the answer to our original question is just infinity. Okay, now let's see here. 1, 0, there it is, infinity right in the middle. So that's C, and that's going to be our final answer. All right. So we've got 2 more questions to go. 1 more multiple choice question with question number 5, and then the big written question. So I will see you guys for those videos in just a bit.